Alright, so today we're going to be talking about return types. It's the last part of our whole function series here, the function portion of the series that I've been working on. This is also probably going to be the last video in the series for a while because I'm going to be focusing on standalone tutorials and stuff like that. I'll be adding to this here and there as things come to me, but for the most part, I think it's best practice for you guys to move on and actually build a game now. Go to my 2D platformer series if you've never made a game before, or you can go to somebody else's series too, and, well, it'll hurt my feelings a little bit, but you're fine. You can do whatever you want, guys. Yeah, you guys should definitely be building games at this point. Like, once you understand how the compiler works, this knowledge starts to become useless unless you're using it within context. But I want to finish off and really talk to you about how functions work. We're going to build this today. A very simple system, and you can see over here the player health and the enemy attack. And it's really going to, if I hit the play button, it's going to lower the health every frame. Hopefully. Hold on. There it goes. It's lowering the health every frame of the game, and you can actually increase the attack here to make it lower quicker. And then if I tab out, it'll go way faster, right? Or I can make it 99, let's say, and go even faster than that. And I can make it, 199 to make it go really fast down. And then it'll go, go, go. And, you can kind of mess with this number and just kind of see how fast the player health is going down. And we're literally lowering it every update frame of the game until we get all the way down to 0 and the game has ended, just goes off. 0 right there. It's going to be your final challenge, is going to be to build this system and to have it print out something different every frame of the game depending on what the health is, and then have it print out the game has ended if the game, if the player's health is greater than 0. But anyway, let's actually talk about how to go about that, the knowledge that you need in order to make that return type work. So let's talk about return types. Alright, so first thing first, clear out everything once again. We don't need anything inside of here. We're going to start from scratch again. I'm actually going to get rid of this. We're going to be talking about return types today. I'll leave the comment in there. We're going to be talking about return types today. We've been using it so far. We've been using void, which means that you don't need to return with anything. Now, in that whole, you're going on a vacation metaphor that I've been using all along, the parameter is kind of like your ticket to wherever you're going. In order to get to that function, to get to that land, you must bring the parameter that they're asking for. If you don't have the parameter, you're not allowed in. Well, you're not allowed to go back home unless you have the return type with you. In the case of void, they're just saying you don't require any luggage to come home. You can just come home. We're going to let you back home, no problem. But if you don't have this return type with you, you're not allowed back home. If you don't have the right luggage, you can't come home without that luggage. You must come home with the right return type. Okay? So let's kind of show it off a little bit first. So we're going to do a quick Boolean one. Oh, sorry. That wasn't good. So let's make a quick one. Let's make a Boolean, and let's make it called is on the short list, right? And it's going to take in a string, a name, and it'll return true or false based on what the string name is, right? So basically, pretend like you're a bouncer, right, at a club or something like that, and you have to check a short list to see if this person's a VIP or something like that, right? So and we're going to take in a string name to check this list. So there's only really a couple names on there. So if the name is equivalent to, let's say, George Freeman or something, I don't know what any names are, then if you do this symbol right here, I'm going to show you this. You might not have ever seen this before. These two lines, these are right above your enter key. This means or, right? This is what this symbol means. If I hover over it, it might even show you. It's not gonna. It means or. So, or if the name is equivalent to, let's say, Jessica Yen. I don't know. I'm just making names up. Or the name is equivalent to Habari. I like Habari. So if any of these things are true, so if this is true, or this is true, or this is true, this whole thing will return true. That's what will happen here, right? This is different from the AND. If the AND makes it so that you have to have all these things true, or makes it so if any of these things true, this whole thing is true, right? It's just one giant true Boolean, right? So then we'll return true, right? And because the if statement always takes in a Boolean, and this return statement takes in a Boolean, the truth is you can actually just copy this whole thing and do that, right? And so this whole thing right here will return true or false if any of these names are true or false. So just in case you guys don't understand what just happened there, I'm going to explain it one more time. So right now, you could actually make it so this is, you know, like this. And this is where a lot of like people that first start coding do things. This whole thing though, if you think about it, an if statement actually takes in this whole thing right here, turns out to be true or false, right? So really, if I just return this statement right here, if I just return this Boolean, because that's all this thing is a Boolean, it's a true or false statement, and it has to see if the name is equivalent to this, or this, or this, then it's going to be true. If none of these are true, then this whole thing is false. In other words, we don't need an if-else statement because this thing will return true or false the same way, right? And again, if you're not used to that syntax yet, you'll get used to it over time. Don't worry about it. It's not something that people tend to understand right off the bat. So this whole thing is equivalent. It's the same thing as what I just wrote with the if-else statement. Leave it as an if-else if you're really confused right now. Anyways, this will return this if one of these names is equivalent to the name that's given. So if I go over here, and I go if is on the short list, and I'll check to see if Derek Jeter is on there. I don't know. And then I'll simply print welcome in, right? If he is, right? Else print wait in line, punk. Or something like that, right? And then just for fun, we'll test the other, let's say is on the short list. We'll test the other possibility here. And what's the name I had on there? Oh, Habari. Let's say Habari. Right? And of course we say print welcome in. And else we'll print wait in line, punk. Right? So let's go ahead and do this now. So we're in the console, wait in line, punk, welcome in. So we welcomed in the first name, which was not, it was Derek Jeter. And the second name, we totally welcomed in because it's Habari. You always let him in. So you get the point here. Like, you can actually do something pretty cool because this. So what's happening though? How is this is on the short list working, right? So what's going on here is this whole thing right here is this Boolean is returning with this luggage. It returns with this. Before, we didn't have anything after this. It returned void. So when it got done with this method, it would go like this, and there'd just be emptiness there. But now we're actually returning this whole thing. So what happens is we feed in that name, Derek Jeter, and it goes, is Derek Jeter equivalent to George Freeman? No. So this part's false. So this false. Is Derek Jeter equivalent to Jessica Yin? It goes, no. And it goes false. Is Jessica Yin, is Derek Jeter equivalent to Habari? Then it goes, no, it's false. Now, or makes it so that if all of them are false, then it's automatically false because it's or. So it's false or false or false. Well, none of them are true, so there's no or here. You know, only one thing needs to be true in a bunch of or statements for it to be true. So it goes, okay, well, I guess they're all false. And really what it does is it goes one by one. So it goes false or false. Well, that's a false. and then it goes false or false, and then it goes false again, like that. That's what it does. Then it hits a semicolon, so it returns false, which is a Boolean. Booleans are true or false. So then it goes on here, and then Derek Jeter becomes false, like this. So if false, print welcome in, else print wait in line, punk, right? Now, what's crazy about this is that if you go with the same thing here, and we go with Habari, it does the same thing here. So you take the name Habari right here, it goes, okay, Habari is not equivalent to George Freeman, so no, that is a false. Jessica Yin, also a false. But is Habari equivalent to Habari? Yes, that's true. And so false or false, remember, only one of them has to be true for the whole thing to be true. But false or false is still false. So this is false right here. But false or true, well, one of them's true, so then they're both true. That returns true right there. So then it goes return true, and this true goes off right here like so. And then once that happens, you get welcome in, just like that. I hope that kind of made sense once I went through how the compiler works on that. So it returns with that, whatever this boils down to, it returns with that true or false. So I'm saying when it gets to the end of this parentheses, it erases that basically, and it returns with whatever this has on side of it, whether it's a true or a false, right? That's kind of important. It was returning with nothingness when it's a void, but it returns with whatever this comes after this return statement. It has to bring something back. If you try not to bring something back, if you go like this, and I just put a semicolon after this will automatically give you an error. They're saying, no, you have to bring back true or false. You're not allowed to come back home without it. So that's kind of the gist of how a return statement works. You can do this with any kind of variable. You can do it with string. You can do it with anything. You can even do it with classes. You can even do it like I could literally write in first class, which is the class that we're inside of. Right? Oh, first script. Wow, I was like, can I not do it? First script, and then you just have to return a first script, which is what this thing is. So that might be beyond you guys right now, but I could do a battler, for instance. I can make it so you have to return a battler on here, right? And then you can see this thing goes away because this thing is actually a Boolean. So it doesn't work. That's the type of data this is. So you can do this with any data type, even classes that you make is my point here. Now this is a Boolean though. We have to return it. So return type can be any data type that's inside of your project at all. So Boolean, strings, integers, floats, those are all common ones to use inside of Unity, but you can do it with anything, including classes that you make. Okay, so now that that's done, let's actually go to the challenge, that big challenge I showed you at the beginning. The point of this challenge is that you're going to need to make a couple variables here. First thing first, you don't want this, you're going to want it to run an update, but you're going to want it to not run an update if the game is over. So the first thing you're going to want to do is you're going to make a Boolean is game over. That's going to be set to false at first. And now, if this is ever true, you want to be returning out of this update, right? So that's your step one. You want to return out of update if the game over is true. If it's not true, otherwise, you want to be running something else. And it's going to be, you're going to want two integers for this. You're going to want a player health. And we're going to set this to equivalent to a big number, like as big as you can make it, basically. And we're going to make an int an enemy attack, and we're going to make that equivalent to 1. Okay, so what's going to happen here is if the game isn't over, if you're not, if you're getting past that first part I talked to you about, so again, if the game is over, you're going to want to be returning out of this update function. You're going to want it to stop so nothing else after that runs. Now, if you're getting past that, you're going to want to actually lower this, and we're going to want to do this within a function. So you're going to want one function to print out something. You're going to want a different string depending on how this function runs, right? So you're going to want a string type return type function, and you're going to want to be putting it inside your update, so you're going to want to print something out, and it's going to be different. And within that function, you're going to want the player health to go down by the enemy attack. That's one thing. So the player health has to go down by the enemy attack. And then you're going to want to return a different string depending on what's going on, but depending on whether the player is still alive or not. If the player is still alive, if his health is greater than 0, then you're going to want to print out the game goes on and player health is and whatever the player health is. And if that player is health is below that, if the player's health is gone, then you're going to want the game over to go off, and you're going to want to set the player health to 0 because it's going to go down too much if you've got the number. You'll see what happens. So if the player health is 0, though, you're going to want the game to say the game, you're going to want to return the string, the game is over. And you're going to want to set the is game over to true. Okay, you got all that? It doesn't matter what you name the function, just have fun with it. Go ahead and try that now. Alright, so first thing first, we got to make it so that it gets out of this if the game is over. So we don't want anything to run if the game is over. And in order to do that, you simply go if is game over, return. That way you get right out of this update function right off the bat. You don't get anywhere lower than this, right? Because remember, the point of every function is to return. So if is game over is true on this, then it doesn't matter what I print out underneath this. This will never happen. Because this will never happen if this is true, right? It's basically equivalent to writing is if true. And then you'll see that all blink it out, kind of gray out, because this will never run now. This code will never allow that to run. But anyways, we're going to make this back to false. We're going to make this back to is game over. I was just kind of trying to show you that it'll all gray out. And we're going to get rid of this. And we're going to go ahead and make our game work. So we're going to make that function that I was talking about. And we're going to want to print out whatever it returns. So we're going to print. And we're going to make a string type function. We're going to say run game or something like that. It doesn't really matter what we name it. Ooh, I misclicked. There we go. Now, if player health is greater than... Well, the first thing we need to do is we need to lower the player health by the enemy attack. So we're going to do that first. And honestly, it's not really good practice to do it inside of this function. What you really should be doing is actually doing it right here. Player health minus enemy attack. Equals player health minus enemy attack. You should be doing it like this. Like, you should be printing it out before you do the printing and not running inside this function, because it's just bad practice to actually do it inside of the function and have this function do so many different things. But just for fun, we're going to do it in here anyway, just because I want to. So minus equals is actually a faster way just to write what I just wrote. And if we hover over it, you'll see what it actually does. This is actually one operator. So putting these two symbols next to each other is one operator, kind of like the OR symbol is two symbols together, but it's one operator. It does one thing. This whole thing right here equals OR. Well, this minus equals is actually one basic symbol within programming. And what it means is it actually takes this first thing right here, and it basically does this. It goes, okay, I'm going to take that variable right there, and I'm going to do this. Ugh. So that's what the compiler does when you have that symbol written, right? It's the same thing. Ugh. Why is it not working? It's the same thing as writing that. And the thing is, you can change this to different symbols too. Like plus equals will do it as well. You can multiply as equals. You can do a bunch of things like that. Okay. Well, that's the first thing we're going to do. So if player health is less than 0 or is greater than 0, we'll keep on running the game, right? So we'll simply print out, or we'll return the game goes on, player health is, and then we'll print out the player health. Okay. Else, this is where things get a little bit fancy. We'll have to put the curly braces here because we're going to do more than one line of code. The reason why this works without curly braces is because this is only one line of code. If you only have one line of code after the if statement, then the compiler actually just assumes that you have the curly braces around it. This right here is basically it with or without the curly braces is the same thing to the compiler. All right, and so right here we'll actually do something a little bit different. So once the health is actually at 0 or lower, what we're going to do is we're going to actually set the health to 0, because, no, I'm not going to do that at first. So the first thing that we're going to do So is game over becomes true in this case, right? Because our health is too low, is game over is true, and we shouldn't be printing out something every frame of the game anymore. Then we want to actually return the game is over, right? Just like that. And then we, inside this print right here, we're going to actually run the game. So we put the function over there, and he'll take that vacation down here, and he'll bring back either this piece of luggage or this piece of luggage, depending on what's going on here, right? If we go back into the game now, you'll notice right off the bat that we don't have any access to those variables over here on the right side of our screen. If you haven't given yourself access to those variables, go ahead and do that now as part of your challenge. Okay, so we're going to go back inside the code over here, and to get access to those variables, you can do it in multiple ways. One is you can actually serialize the field like this. You put the square brackets around it, and you put in the term serialized field. This is actually a Unity term right here, and this will actually serialize this field and actually put it inside of your inspector. You can also make a public variable, and all public variables are automatically serialized. And that'll also work, but this actually gives you access to this variable outside of this class, and that could cause you problems later on. So generally speaking, you don't really want to make something public unless you absolutely have to. But for now, while you're first beginning, it's not a big deal if you're using public variables. You can kind of fix that later on if you need to too. So let's go ahead and save, and let's run this whole bad boy up. The health should be going down. It is. Look at that big number. We're going to go ahead and make it into something else. Let's make it like 999. Boom. That's going down by a lot more now. Let's add, like, 0 at the end of that. That should go down even faster now. Not quite fast enough though. Let's go ahead and make it to, like, let's make it 5 digits, so 50,000 maybe. 3, like that. There you go. That's fast enough. And then boom, we got over there. Now the only problem here is that your health gets so low. Look at that. You're negative 6,803 at the end of this game here, and if you were printing that out in any way, it would look weird. So one of the things that we want to fix inside of here is that we can actually make it so the player health is actually 0 at the end. And you just do that right here. Equals 0. And actually the best practice is simply to make it so that this never gets below that. So you can actually say the player health right here equivalent to, and you do mathf dot, you're going to do the minimum, no, the maximum between two different numbers. One is going to be player health minus enemy attack, right? And the other option right here is going to be it's just going to be 0. And so this will pick the maximum between this. This is a class right here that you can use. This will pick the maximum between any amount of numbers that you put in here. So player health minus enemy attack, and it's going to pick the bigger number between both of these things. If this becomes a negative number, then we'll automatically have 0 for the health. So the health will never go below 0 in this case, and it's kind of just fixed right here. It's a nifty way to make it so that the health won't change too much. You can also do this in other ways too, but I'll show you those things later on. You don't need to memorize that yet. I'm just kind of showing it to you so that you know that methods like that exist. But if we change this back to 50,000 again and have this number go down really faster hopefully. Maybe I should make it 500,000. There we go. And there we go. You see it hits 0. It never goes below it. And there we go. The whole thing works. We're done. This is it. That's all that you need to know for how functions work at this point in your life right now. I know I talked a lot about in this video about like good coding practices and stuff like that, but to be honest, you don't have context yet to know what good coding practices are and why they're working and stuff. It's kind of something that you learn as you're making a game, which is kind of the point of why I'm saying you got to go make a game now. So that's it. Go make a game, my friend. It's time. I'll eventually be posting. Well, I'm actually working on a Udemy course right now. I'm making a Metroidvania. It's I'm still in the beginning phases of it. I'm only like 5, 6, 7 videos inside of it now. But as time goes on, I'll be releasing more details on it, and I'll send out a launch notice to all my subscribers and everything like that, so that you can sign up for it if you want. It'll cost $10 if you sign up through my link, which is pretty cool. But yeah, so I'll be releasing that, and people can sign up for that. So that's a place where you might want to start. You can also start with my free platformer series. That's here on YouTube. If you haven't done that already, that's a really good place to get started. There are other people that have made good starting points here on YouTube too that are free. I'm sure that you're able to at this point. You should, once you understand the compiler, once you get how it works, you can kind of just pick up other people's coding standards and try to figure it out. My biggest point of advice for you right now is don't get so caught up on what other people are telling you are good coding practices, and really try to figure out why they're good yourself. Like, don't listen to somebody just tell you what's good coding practice. Listen to why people tell you what's a good coding practice. Listen to why the DRY principle works, which is do not repeat yourself. Listen to that. Listen to why you don't want to repeat yourself inside of code. Don't listen to just don't repeat yourself. I found that like a lot of people have a lot of opinions that are very subjective about what good code is, and I find a lot of people get confused. I get questions so much about what makes good code good and bad code bad and everything like that. And the truth is, it's very subjective. And if you're like me, you're going to be working by yourself a lot. So, like, nobody can tell you how to code well for yourself, my friend. But if you're looking to get a job in this industry or something like that, then there are some good practices and stuff. You can check out the channel Infallible. I'm not going to do that. But again, you're not going to have the context to understand why good coding practices are good coding practices until you actually go through and build a full project. In other words, you got to go make a game. So I'm going to leave a link to my Ko-fi account down in the description below, where you can donate me a coffee if you feel so inclined. But by no means is it necessary. It's not something that it's, you know, I'm just so much more grateful for your time than anything else. And I don't want anything to detract from that. So please leave a like, hit the subscribe button, leave me a comment down below, and that's it, guys. Thanks so much for this time. I hope you guys have a happy time making all your games. Bye.